Hey everyone, welcome to my channel. I have started a personal DSA challenge where I am solving 5 problems per pattern, covering 180 problems in total. I'll be posting one video per day explaining my thought process from brute force to optimized approach. If you're new here, you can check out the previous videos to follow along. In today's video, we'll work on subsets. So the problem states that we are given an integer array nums containing unique elements and we need to return all the possible subsets. A subset means any combination of the elements including empty set, single elements, full array and everything in between. So here the order doesn't matter. So the key insight here is for every element we have two choices. Either we pick it or we will not pick it. So this creates a decision tree and exploring that tree is called backtracking. Backtracking means we will choose, explore and undo the choice, which means we keep adding the elements then remove them to try other possibilities. So the code for that goes like this. The return type of it is nothing but list of lists containing all the subsets. So let's initialize it first as result. New array list, and we will start backtracking from index 0 with empty subset. So let's call a method called backtrack and we will pass the start as 0 and then the given input array nums and a new array list. You'll get to know why. And we'll also pass this result. Right. And at the end we will return result. Now let's implement this backtrack method. The return type would be void, and because we are just updating the result in each iterations or each calls I would say. And for the backtrack method the input arguments are start index, input array, and this new array would be the current array. So let's call it as current and we will also pass this result as this. Now first we will add a copy of current subset to the result. So result dot add new array list of current. So a copy of it is added to the result. Now let's explore further elements. So for that we will start iterating from start index. I starts from start, I less than the entire length, I plus plus. And now we need to follow 3 steps for backtracking. 1, we will choose or we will pick the current element, we will explore and then we will undo it. So first for choosing, let's add the current element which is nums of I to our current array. This is choosing. Right, now we will explore it, which is nothing but we are moving to the next indices. So we will call I plus 1 and the nums, current and result. The same method. This means we are exploring different possibilities from that index. And now we will undo, which means we will be removing the last element. That is why this is called as backtracking, because we are undoing and we are coming back. So we will remove it. So current dot remove of the last element, which is nothing but current dot size -1. This is undoing. Alright, let me run the code. Okay, I'm submitting it. Cool, it is accepted. So for example, let's take a small example of input as 1 comma 2, and initially the start array or the start would be empty. Then we will add the current element. We will add 1, and then we will explore it. So we will add the next element. Initially, wait, sorry, this is not start, this is result. Initially we will add 1 to the result, and then we will explore it from there. So we will add 1 comma 2, and from there we will undo it, undo the last element. So we will have 1 again, we are backtracking it again, we will undo it, then we will have empty, and then we will add 2. So here every element has 2 choices, either we pick it or we will not pick it. So the total subsets would be 2 power n. So the time complexity would be 2 power n, and the space complexity would be O of n because of recursion depth. So this problem is kind of a foundation for the future problems which we are going to do under this backtracking playlist. So if you understand this problem clearly, then you have taken the first big step in mastering backtracking. Next we will solve other complex problems. So that is it for today's video, and I'll see you in the next one.